This is section 5.4 continued, and what I want to do to start this second part of our notes today is to give another example of using the factoring by grouping with our box here, and then I'd also like to talk about a couple of special cases of factoring. But let's start with another example of how to factor using grouping and using our box with our factoring. So if you remember from the last part of our notes, if I'm going to factor this by grouping and use the box to help me organize that, the first thing I have to do is put my first term in the first box, so that's going to be a 3x squared, and my last term in the last box, so that will be a negative 5. Then to figure out what to put in my other two boxes, I multiply the a and the c together. So my a and my c, I'm going to multiply those together, and I'm going to get a 3 times 5, which is 15. So I want to start listing the factor pairs of 15, which there's not very many. You get 1 and 15, or you get 3 and 5. Okay, so with this method, once I figure out my factor pairs, then I find my factor pair that I could use to make a 14. And since my 15 is technically negative because of the 3 and the 5, I'm going to use the 1 and the 15. And to make a negative 14 in the middle, I would have to use a positive 1x and a negative 15x, and that will make a negative 14 for the middle. Once I have all my boxes figured out to do my grouping, I'm going to use my greatest common factor. So if I go across for the rows first, 3x squared and 1x, the greatest common factor of 3x squared and 1x here is going to be just an x. So out here I will put x as my greatest common factor. Then in the second row, the negative 15x and the negative 5, because these are both negative, when I factor out my greatest common factor, if both are negative, then you can include the negative as part of your greatest common factor. So for that, my greatest common factor is actually going to be a negative 5. Okay, then I'm going to repeat the process doing the columns of these. So 3x squared and negative 15x, my greatest common factor is going to be a 3x. And 1x and negative 5, my greatest common factor is a 1. So when I look at this after I've done my two binomials, this tells me that since one sign was positive and one was negative in the middle, my signs in my binomials will be that way. And since the x has the negative 5 over here, it's actually, that will be my parentheses that gets the minus. So it's 3x plus 1 and x minus 5 is how I'm going to factor this. Okay, so that was just another example of using the grouping to do my factoring and using a box to help me with that. The next thing I want to talk about is a couple of special cases of factoring. Now, I'll be honest, if you can factor, really, if you factor this as a perfect square trinomial and you notice that it is, great. If you don't, you'll still get it factored when you're finished. The one thing I want you to notice about this is that when I factor these, what's going to happen is they're actually going to have the same binomial terms. So you're going to have, or binomial factors. So you'll have a plus b and a plus b, or a minus b and a minus b. Okay, so if you look at my examples down here, let me show you what I mean by you would be able to factor these. Okay, what makes them special, you'll notice, is that the first term up here and the last term of these, okay, they're always going to be perfect squares. So you're going to have a perfect square at the beginning and a perfect square at the end. So that should be a hint to you that this might possibly be the case of a perfect square trinomial. Not always, and that's why I say it's not always a guarantee. So what we're going to do is we're going to try to figure out how this would factor. But if I have a perfect square at the beginning, like for example here I have x squared, and I have a perfect square at the end, 9, you'll also notice that it's plus both times at the end, not a minus. Then I'm going to check and see if this factors as a binomial squared. So in other words, what am I squaring to make x squared? Well, that would have to be x. So I'm going to end up with x and x. To make 9, since I think this is a perfect square trinomial, I'm going to try 3 and 3. Okay. If I try 3 and 3, will I get 6x in the middle? Sure. 3x times, or x times 3 is 3x. 3 times x is 3x, and 3x plus 3x is 6x. So I'm going to write this answer as the quantity x plus 3 squared. So anytime you see a perfect square at the beginning of your trinomial and a perfect square at the end of your trinomial, you should probably try the perfect square trinomials and see if it factors that way first. Okay, same thing here. My question would be, is 4x squared and is 25 a perfect square? And the answer is yes. For 4x squared, I could use a 2x and a 2x. And for the 5, I can use a 5 and a 5. Now, since this perfect square trinomial has a minus in the middle, both of my signs are going to be minuses. And you can check this. 2x times negative 5 is a negative 10x, and negative 5 times the 2x is a negative 10x. Negative 10x and negative 10x make negative 20 in the middle. So I'm going to write this as 2x minus 5 quantity squared. So I'm going to write it as the square of a binomial down there. Okay, so again, if you catch these, great. If you don't, you're still going to factor them the same way. You could use the factoring by grouping. You could just do the guess and check. You're still going to get those same two binomials no matter what method you use to factor. Okay, now the last one that we're going to look at for a special case is a difference of two squares. And this one's very unique. Again, you're dealing with two perfect squares. And when I have two perfect squares with subtraction in the middle, those will always factor into what we call conjugate binomials. And conjugate binomials are binomials that have the same terms in each binomial, but the sign in the middle is different. So you'll notice one says a plus b, and the other says a minus b. Again, you could still get this by trying to factor, right? What's my middle term that I'm trying to get if I have just a squared minus b squared, and I would be trying to get a 0 for my middle term, okay? But if you see these and you can recognize them, it just makes them a lot faster to factor. For example, x squared is a perfect square, right? X squared is just x being squared. 16 is a perfect square, right? Because 16 comes from 4 squared. So if I can figure out then what my binomials are for these two, I've got perfect squares on each end, and I've got subtraction right here in the middle. This won't work if there's addition in the middle. If I have two perfect squares with subtraction in the middle, I can still factor this into two binomials. Okay, and my binomials are going to look like this. Again, to make x squared, I have to multiply x times x. I've got a negative 16, so my signs have to be a plus and a minus to get a negative 16. And then to make my middle term come out to be 0, I have to have a positive 4 and a negative 4. That's the only way this is going to factor. Okay, so again, with these special cases, it's just a matter of if you recognize them and you know that something specific is going to happen every time you see this, it just speeds up your process of factoring for you. Okay, it's kind of like having your multiplication facts memorized. All right, so 9x squared minus 49. Let's think about 9x squared and 49. Would those be perfect squares? Okay, and that would be true. 9x squared is the quantity 3x being squared, and 49 is 7 being squared. So if I'm going to make my binomials here, my conjugate binomials, both are going to start with 3x. Both are going to have 7. One will get a plus, and one will get a minus in my binomials. So there are my conjugate binomials. Okay, last example over here, 16x squared. 16x squared is a perfect square. I square 4x, right? 4x times 4x makes 16x squared. I square 1 to make 1. Make my binomials 4x and 4x, because that's what I squared to make 16x squared. 1 and 1, put a plus and a minus, and those are my conjugate binomials. Okay, so the special cases, although they're nice, and if you see them, you can make your factoring go much quicker because you know what's going to happen with them. You can also still reason them out using any of your other methods for factoring.